All right, I want to talk about expected value, and expected value is, in the context of some of the things that we'll be talking about in class, how much money you can expect to win in either a game or some situation where there's money to be won over the long term. So if you played this game over and over and over and over for forever, how much money could you expect to win on average? Okay, so in this first one, imagine that you're playing a game where you pay $10 to draw a marble out of a bag. There's 5 black, 3 blue, and 2 red, and you can see the prize breakdown there. If you draw red, you get 100, blue 20, and black you only win $1. What is the expected value over the long term of the game, and is it worth playing? So to figure this out, we're going to figure out first the probability of drawing a red marble, and then the probability of drawing a blue, and then a black. So the probability of drawing a red marble, we'll call it probability of red, is equal to the number of red marbles divided by the total number of marbles. So that's 2 over 10, which simplifies to 0.2. Okay? Then we'll look at the probability of drawing a blue. So the probability of drawing a blue, number of blue marbles over the total number of marbles. That's 3 over 10, or 0.3. And then last, we'll look at the probability of drawing a black, and that is going to be 5 divided by 10, or 0.5. Okay, so we find those probabilities, and then define the expected value, which we call E of x, where x is the random variable, is to take the probability of red and multiply that by how much money you're going to win if you draw a red. Take the probability of drawing blue and multiply that the number of how much money you're going to win by blue, and the same thing for black. So we will take 0.2, no, that's right, 0.2 times 100 plus 0.3 times 20 plus 0.5 times 1. Multiply that and add it up, and you should be able to put that all right in your calculator, and you're going to get $26.50. Okay, so you're paying $10 to play the game, but your expected value in the long run is $26.50, so this is a pretty good game to play. Let's do another example. In this one, you've got a spinner, and you're just going to simply spin the spinner, and depending on where the spinner lands, that's how much money you're going to win. So let's suppose that this is your spinner. In this one, we're not going to have to figure out the probabilities at all. We're just going to have to find the expected value. So the expected value, we write E of x is, sorry, that is pretty poor penmanship. So E of x is equal to, and we're just going to go right around the pie chart. So we're going to go 0.2 times 0, even though that is only 0, plus 0.36 times 5,000. And notice that I'm changing all of the percentages to decimals. I'm going to run out of space here, but we'll just go down on the second line. So plus 0.22 times 10,000 plus 0.14 times 15,000 plus 0.08 times 25,000. You have to change all of those to decimals for this to work, okay? So you don't want to put in 22 for 22%. If you multiply and add up all of this stuff, you end up with an expected value of $8,100. Okay, so once again, take the probability, multiply by the amount of money if you win that, or if the spinner lands in that section. All right, we have one more example. Okay, in this one, you're given a table of values, and it's a frequency table. And so what you have to do in this one is figure out all of the probabilities, similar to number 1. So that we're going to do that now. Remember, probability is the number of successes divided by the number of total outcomes. So we got to figure out the total outcomes. So we're going to take 200 plus, in fact, let's do this, 200 plus 50 plus 25 plus 20 plus 5. We're going to add up all of those, and you get a total of 300. Okay? So then, for the probability, we're going to take, for this first probability, we're going to take 200 divided by 300. All right, and that's going to give you 0.67. All right, and then you're going to take 50 divided by 300 and see what that is, and you'll get 0.17. And then you're going to take 25 divided by 300, and you're going to get 0.083. And then you're going to get 20 divided by 300, that's 0.067. 0.067, and then last 0.017, and that is if you take 5 divided by 300. Okay, so you do that over and over and over again, and then once you've set up your table, you're going to find the expected value. So you're going to go expected value is equal to our 0.67 times 0 plus 0.17 times 5 plus 0.083 times 10 plus 0.067 times 20 plus 0.017 times 50. All right, and then you're going to add up all of that and see what your expected value is. The expected value for that is 3.87. Right? And so that's $3.87. It's the expected value for this raffle. Okay, we're not going to do the theoretical distribution. We did that yesterday. So that's it for expected value.